All right, so here's our real world problem to go with this section on rational functions. You are planning to install sod in your yard. You calculated that the installation will require 240 rolls, and you have placed an order. Unfortunately, the delivery person read the address incorrectly and dropped off the sod at a house a block away. I don't know, that doesn't seem very fair. The delivery truck came from out of town and will not be able to return to help you move the sod. Too bad for you, right? You begin to contemplate the effort it would take to move the sod, and you consider various means of transportation, and you're very creative in your means of transportation. And so each piece weighs about 12 kilograms. Don't remember how many pounds that is. I think was it 2 kilograms, 2.2 pounds, something like that. It's one way or the other. Yeah, okay, yeah, 1 kilogram is 2.2 pounds. All right, and so each piece weighs about 12 kilograms. So you make the following estimates. So this is the transportation method, and this is how many rolls they can move. So some of them you're going to have to cut the rolls into pieces because they can't move a whole roll. The neighbor's cat can take 2/10 of a roll. The 7-year-old next door can take half a roll. The 12-year-old next door, a little stronger, they can take a whole roll. You're stronger than the 12-year-old, you can take 2 rolls. Your friend's about the same strength as you, so if you work together, you can take 4 rolls. A wheelbarrow would be a good idea. You can carry a little bit more. You can carry 5 rolls. If you use a wagon, that'll carry 8 rolls. You can use your car trunk and carry 15 rolls, but that's going to be messy and you're going to be spending the time cleaning up your car trunk. Or a pickup truck, if you have one, and you can carry 40 rolls at a time. So let's take a look at the number of trips required. So how would we find, if we know how many rolls they can move, and we know that there's 240, how do we figure out the number of trips it takes?
We'd have to add up, first, how many altogether, everyone can take.
Oh, everyone's not going to go together. You're going to use one transportation mode at a time and see. Yeah, if all the transportation modes work together, yeah, that would be a little harder of a problem, a little harder to graph. But how would I find? So if I have this total, and this is how many it can take, how would I figure out how many trips it's going to take?
Divide the amount that it can take by the 240.
Right. Yeah. So if you can take this many, if you divide by how many you can take, that tells you how many trips, right? Yeah. Kind of like if you had 10 cookies and you can eat 2 cookies at a time, how many cookie eating episodes? It would be 5, right?
Yes.
Nothing to do with this, right? All right. So neighbor's cat. So we're going to divide. Rather than dividing by 2 as a decimal, let's change that to a fraction. What's 2/10 as a fraction? 1/5. All right, so we have 240 rolls, and we're dividing by 1/5. Dividing by 1/5 is the same as? Yep. So that's going to be 240 times 5, so that's 1,200, right? All right, so it's going to take the cat 1,200 trips to move all the sod. Maybe not the best method. The 7-year-olds can take a half a roll. So if we divide 240 by a half, how many is that going to be?
240 by a half?
120.
No.
Wait.
If I cut something in halves, and how many pieces would I have? 480.
Oh.
You multiply by the rest of it.
Yep. Of course, 240 divided by 1 is going to be 240. 240 divided by 2. Switch colors here. Trying to color code it so it's easier to read. Yep. And then 240 divided by 2 is 120. And then divided by 4. That doesn't look very purple now, does it? I hit purple. I know. Here, I'll just use blue. So 240 divided by 4, 60. And then 240 divided by 5.
48.
And 240 divided by 8.
30.
And 240 divided by 15.
60. 16.
And then this one's one of the easiest of all, 240 divided by 40.
6.
Yeah. Well, not as easy as 240 divided by 1 or 2, but pretty easy. All right, so we're going to graph these. Which is the independent variable, the x, and which is the dependent variable? Time is x, yep. This is our independent right here, and this is our dependent. So how many trips it takes depends on how many rolls you can take at a time. The more rolls you can take at a time, the less trips you're going to make, right? And if you're not very strong like the cat, well, you're going to be walking back and forth a whole lot of times. Meow, 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 meow. As he carries the load of stuff, right? I was pretty good on the y. I like the y, so I didn't erase it. So this is the number of trips. There were 10 spaces, so I counted by 120s. Because the cat took 1,200 trips. I did consider the best mode of transportation. If the truck, when I first graphed it the first time, if the truck that originally brought the sod would have just brought it to the right house, then it would have been one trip with all 240 rolls of sod. But when I did that, my numbers were all crunched together. So we're going to leave off the fact that the truck could have just brought them, and that would have been one trip. And instead, we'll go with the trips that it actually took, using all of our various modes of transportation. All right, so here's the number of trips. On the bottom, we want how much they can carry, right? So it's the amount of rolls. So the number of trips is the y. Let's see if we can scroll. And this is the number of rolls. Oops. Really wish they would fix this orientation. So I don't have a crooked board anymore. All right. Number of rolls. So what was the most rolls that any of the modes of transportation could carry, besides the original truck? The most. 40, right? So let's just go up to 40, rather than going up to 240, where all the numbers get crunched together. So let's see. I think there's 10. 1, 2, 3, 4, 5. There's 10 spaces going across. So we'll count by 4s. Right? So this will be 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. That fits in a lot nicer. All right, so we're going to, and this would be 0. Let's answer the first question. So rolls is R, and number of trips, that's T, right? So R's are X and T's are Y. Can R be 0? Could we carry no rolls? Well, exactly. We could, but it wouldn't do anything to moving the rolls. Like, how many trips would go with that? You know, it'd be an infinite number of trips because you're carrying no rolls. Can the number of trips be 0? No, not and move them. So while you can carry no rolls and not help at all, it's not very logical, as you said, in the context of this problem. So when someone first period asked, well, couldn't they be 0? Well, technically, but not in the context of this problem. So we will say no, not in the context of the problem. It's just not logical. Not in the context of the problem. All right, so let's do domain and range. I suppose we could include the original truck. Right. So domain is the number of roles. So theoretically, what's the least number of roles we could carry?
1.
Well, how many does the cat carry?
0.2.
Yeah, 0.2. But what if we got like a mouse, you know, and we stick a couple grains on them, right? I mean, they could theoretically carry, if we had a really smart mouse, theoretically could carry some of the side. So what should be our starting point that we may or may not reach? What should be our, not quite, what would be our, because I don't know how much the mouse carries. And then I could get, someone in my first period said we can get a cockroach and stick a little bit on them. So what should our starting value be for our domain?
0.
0. Right? Negatives would have absolutely no sense, right? You couldn't carry a negative number of roles. What does that mean? Put them back, or I don't know. Add roles to the pile? So we're going to use 0 for the domain. Notice I used a parentheses because we're not going to include 0, but I mean, I don't know how much smaller we can get if we get some other animals. What was the most number of roles that we could possibly take? 240. That's all there is, right? If you've moved 240 roles, there are no more roles to move. And that we could actually do. The truck did it. Right? So R is the range is the number of trips. So what would be the least number of trips? 1. Yeah, now we can't say we took a half a trip. What's a half a trip? Right? That doesn't have any meaning. So we could take 1 trip, and that would be the truck. And then what's the most number of trips that we're going to consider really in this problem? 1,200. Let's just say 1,200 is going to be our, you know, we'll kind of end it there. I mean, let's put a plus next to it, because if we got the mouse or we got the cockroach, I mean, we can take a few more trips, but then I don't know how to figure that out, right? So we'll just put 1,200 plus. All right, so let's graph our points here. And I really wish I had somebody take a picture of them, because now I don't remember them. Oh, can you take a picture of them real quick?
Yeah.
I'm like, I remember the cat and the pickup truck.
I can get my camera to work.
Yeah, that Samsung quality.
Shut up, penis.
You said it yourself earlier.
Huh?
Oh, okay.
Okay, so now so I remember this one. Like, I don't know, 1/5. So that's like really, really small. So 1/5, 1,200. I'll just make it a teensy bit more than 0. All right, what's the next value?
480.
480. So pay attention, guys. 1/2. Don't make me have to reprimand you on camera. 1/2, 480, and the next one?
240.
And that was 1 trip, that's right. So 1 trip was 240, or 1 roll per trip was 240. And then we had 2 rolls, right? The kid could carry, you could carry 2 rolls. So that was 120. And then if you brought a friend, you could carry,
60.
it would take you 60 trips. And then what was the next one?
48.
All right, so 5, you carry 5 number of rolls, you can get 48. And then 8 was?
30.
8 was 30. So now it starts to get hard to even graph them, right? And then there was, I think, 40, and then it's even smaller.
It was 30, the 15 one was 16, and then the 40 was 6.
Okay. So here's our graph. Let's see if we can finish it up. The other class we finished it up. And did more. All right, so what happens to the graph as as the number of rolls keeps getting larger and larger?
It's smaller and smaller.
The number of trips gets smaller. What happens as R decreases to 0? Like The cat, he doesn't carry very much, right? He carries a fifth of a roll. What happens? The number of trips? Trips get bigger.
More.
T gets larger. All right, so we'll do all the closings tomorrow, and we'll start the next part of the lesson. All right, bye for now, people watching.